Hello dear students, we class 12 ki physical chemistry portion dagi unit number 2 koi solution how number tawrisi ko. So unit number 2 solution. Koi solution se how tikanda koi solution ga mari lena ba example tip khara ya noida haye ko. Solution ai ba magi unit se amna essay type question lakali. Koi 5 marks ke essay type questions lakali. Tuna maru ina magi question se numerical based over ko. The numerical se karma jaga ta hangai haiba kanda koi concentration of solution ai koi tamakani aduda numerical over question kar lakani aduda ki koi qualitative properties aina the properties of the solution that depends upon the number of solute particle depend over koi qualitative property koi mari tamakani aduda su based over question kar lakani ko aduna maruina solution haiba chapter sida koi essay type question se dum 5 marks ki se dum lakali aduna today let us start solution. Okay, first of all let us define solution. Solution hai base karino haina koi hana define to risiko when solution hai base homogeneous mixture of two or more non-reacting chemically reactive two or more substance when substance koi component atra constituent hai niko it is a homogeneous mixture of two or more substances. The substances are not chemically react to each other koi chemically react to ko adugumba homogeneous mixture of koi na kari ko we have kind of solution haina khangai adu sida sinari ba term homogeneous mixture hai base kari no hai bido ya pete explain to ko. So in the homogeneous mixture the component of the mixture there is no separation of boundary between the components of the mixture. Akoi mixture du same ba components induki there is no separation of boundary. Haibadi the components must be in the same phase to lagadaba by boundary laitaba ko in the same phase to lagani loina na magi mixture du sariba magi composition and the properties they are uniformly distributed throughout the mixture. Haiba magi composition properties throughout the mixture the uniformly distributed tawuni haibako. That is that homogeneous mixture kore. Homogeneous mixture example yam simple example ama ya noida piraga taki ko. So here we are dissolving the glucose in water. Glucose se water tumbal se ko water tumando. When the glucose is dissolved in water, there is no separation of boundary between the glucose and water. Glucose na karigumba ising da tungi pa taragadi glucose ka water ga separation tongnaba boundary layrano hai, but that means glucose ka water se they are in the same phase to layrane ba ko aduna glucose na water tumba kanda there is no separation of boundary in between the glucose and the water. That means the glucose and the water are in the same phase moi liquid phase to dum layrane hai ba ko loina na in this case we will get the properties of this mixture is same throughout the mixture. My property to some manner ni have ko suppose we glucose thummi dana ko aduna glucose ki thumbagi taste se plug hide solution the loina ko na phangba ngam ngani have ko. That means in the homogeneous mixture the magi composition and the properties sing se they are distributed uniformly some manner distributed away high ne have ko. So this is the definition of homogeneous mixture. Aduna solution kudima ko na kari oini have kanda homogeneous mixture oigani have aduda koina solution sida akoi wakanda liquid ki wakan ngata khali ko the solution sida magi component of solution aina lei magi component du ki physical state kin matungina akoi solution se solid ngakto oiba yaba solid liquid ngakto oiba yaba natra gas solid and different types of solutions akoi lei gani ba that it depends upon the physical states of the component that present in the solution. Solution the yorba component du ki physical state ki matungina we look at different types of solution fangane. So here mainly the solution gi my components se makhalani laigani ko mainly solution is consists of mainly two components. Akoi component ani da sagani kana no haiba kana number 1 is solvent, number 2 is solute, haiba maga solvent amaga solvent is na kaino it is the component of a solution which is usually present in large quantity. Large quantity the yauba component of the solution do kuni kari ko we have kanda solvent ko gune. And solid libas in the kaino it is the component of the solution which is present in smaller quantity. Usually smaller quantity the yauba do component na kuni kari ko ni have kanda koi solid ko gune. Aduna depending upon the number of components present in the solution. Koi solution the yoriba component dugi masingi matungina we have different types of solution koi binary solution, ternary solution, quaternary solution haina koi tangani have ko adu da koi maru ina mainly focus to se class 12 ta koi binary solution se focus to gani koi binary solution have the kari no have kanda the solution which contains only one solvent and one solute koi solvent amaga solute amatanga yauba adugumba component ani khakhtang yauba adum makhan solution to koina binary solution kawi hojita aina pihiba the solution of glucose in water is binary solution. So in this binary solution the glucose which is present in smaller amount that is solid water and glucose na solid water and the water which is present in large amount is solvent water aduna in the binary solution of glucose in water the glucose na smaller amount the yorban solid kaurani adudagi water na larger amount the yorban na akoina kai kaurani haiba kanda solvent water. So let us see the type of solution. Let us see the types of binary solution. Binary solution ki type khara yengasi that depend upon the physical state of the solvent. Aduna akoi binary solution se physical state of the solvent khenabai matungina akoi type khara tholani ko solvent ki physical state se akoi physical state se kaya lai ahum lai dana solid, liquid and gas. Aduna solid, liquid and gas solvent se solid oiba, liquid oiba, gas oiba. Nain to dana solid sisu liquid oiba, solid oiba, liquid oiba, gas oiba. Do it target the binary solution se we will have 9 types of binary solution lakani ko ado ai noida diagram magi table du piraga takiyam ko. So let us see the types of solution. Ahamada koina kange binary solution hai video kuna takre the solution which contains only two components solute and solvent. Solute lamaga solvent lamaga yawda koina kai ko re binary solution ko re. Let us see the type of binary solution based on the physical state of solvent. Koi physical state of solvent based over types of binary solution the table pira take ko. You write down types of binary solution based on physical state of solvent. Physical state of solvent. And then the solution gi magi physical state to kanaga manani haiba kanda the physical state of the solvent duga managa daba ko. Let us see the type of binary solution based on physical state of solvent the ko. Types of solution silani ko solute then the solvent and examples. Let us put some examples also. So the first type is solid solution. Solid solution means where the solvent is solid level. And magi physical state of solution je kanaga manare have kanda solvent ga dum mani ko. Then say koi solid solvent je hai ko. Solid solvent. And we have 3 types of physical state layer ni. Koi solid oiba, liquid oiba, and gas oiba. That is solid solvent da koi 3 types layer ko. The example ko in the PC ko. Solid where both the solute and the solvents are solid oiba ko. Example de koi alloys. The alloys se koi lower class to tamgre. Alloys is the homogeneous mixture of metals and non-metals. Koi alloys piba yare ko. Alloys homogeneous mixture of metals and non-metals. The example of piba yare brass. Brass se kana no alloy of copper and zinc. Bronze piba yare bronze. Alloy of copper and tin. So these are the examples of solid both the solid and the solvent is solid ngak to oiba ko alloys the homogeneous mixture lere mathang na kaino oidoi se mathang na lak to sina liquid solid sina liquid oiba solvent sina solid oiba liquid solvent haiba ko liquid solid solution the example ji kai pibe yare kon hydrated salt koi gi thum da mai lang thopa ko adu se example be yai hydrated salt natraga amalgam alloy of mercury se amalgam kawi amalgam with sodium aduna akoi metal da liquid state ta lebe se kananu haiba kan da koi mercury se liquid state ta lebe ngame ko aduna koi alloy of mercury se koi amalgam of mercury with sodium adun mercury se liquid state ta lebe ngam ko mathana gas solid te ko smaina pibe yare solution of hydrogen in palladium solution of hydrogen in palladium so this is homogeneous mixture mathang da mu yengasi mathangi types na magi solvent se liquid oiba ko solvent se liquid oideba ko adoi targadi the type of solution je koina kai kaurani haiba kanda liquid solvent hairani ko liquid solution da ko liquid solution ain tharas liquid solution or liquid solvent dona physical state ahum laire soluta solid liquid amana gas see example p se ko solid liquid के example p be yarani liquid के example p be yarani gas liquid के example p be yarani कोई solid liquid yam laigre example sidani कोई maru ina ps torok to se ko कोई glucose dissolved in water sitang na sai ta ki do glucose dissolved in water or salt dissolved in water see tum example sam laire glucose dissolved in water liquid sidi kai pibe yare ethanol dissolved in water ethanol si kai tamba water tumba ko ethanol dissolved in water sidum pibe yare si nungai traga khoi si solid lon isala si ko yengma nungai na ko solid hapchalo ko yengma nungai na ko liquid si liquid hapchalo si gas dissolved in liquid ti kana warani ko oxygen khoi gi nga simsina ising da hingbanga mi se oxygen se partially dissolved in water the oxygen je koi tumbanga meba tuna ne aquatic life singsina ko ising manu de hingbanga ngami se ko avana oxygen dissolved in water the carbon dioxide ko edited drinks sai tare ko soft drinks ko coca cola gumba siguma soft drinks da edited drinks ko sida ko carbon dioxide se dissolve tawi adu su piba yare mathangi sina kai oidoiba mathangi types na kari warani haiba kanda gas oiba magi solvent je gas oiba ko gas oidoiba ko the sum the lapto sina gas oi targadi the type of solution je kai kaurani haiba kanda gaseous solution hairani ko gaseous solution or gaseous solvent haisu yare ko gaseous solvent hai tare ko adan my physical state se based on the physical state of solvent the lepi haidu ko sida kai lani solid lani matana kai lani liquid lani matana kai lani gas lani ko so let us give the examples periods table se kitang di thire ko example the solid gas koi yang asiko solid gas ina kai pibi are koi camphor koi karpu se ko camphor mixed with nitrogen gas pibi are natraga iodine vapor mixed in the air su pibi are ko iodine vapor in air that we camphor koi carpudo ko camphor in nitrogen gas camphor carpudo in nitrogen gas so koi dum piba yare solid gas the liquid gas with the taragadi liquid gas koi kai piba yare humidity in air koi humidity in air hai bade koi air the moisture yabudo ko du se piba yare humidity in air natraga we will get chloroform mixed with nitrogen gas isum piba yare chloroform se liquid ni ko gas te koina khangi air is a homogeneous mixture koi air se koi piba yare ko air is a mixture of nitrogen obeyare oxygen obeyare carbon dioxide so they are non-reacting amaga react ko so these are the 9 types of binary solution that depends on the physical state of solvent daina khoi physical state of solvent gi matungina khoi solution binary solution se makal kaya lerani abakan mapal lerani aduna khoi concept ta solution hairaga when a liquid ki wakal ngata khanmado la le ko the solution I mean any homogeneous mixture obe yai the homogeneous mixture obe to the magi solvent ki physical state amusu solute ki physical state khena bai matungina we will get different types of binary solution la kani 9000 koi trinary solution da so la kani the quaternary solution is type of solution se we have so many types of solution lairani adubo koina focus tawdoi se kare tawni haiba kanda noi class 12 ki oina binary solution de koi focus tawbane ba ko sida lere to atopa akoi solution types khare yengasi types of solution that depends on the nature of the solvent when nature of solvent depend on what type of solution kara particular khar lai say for example today noi silver vanina sigi se muthalage ko makha mu akoi mukla asiko to type of solution ji ko akoi mu other type of solution khare yenga si that depend upon the nature of the solvent akoi nature of the solvent depend over akoi type of solution makna ni khar leiri number 1 the aqueous solution ai ba ma ko aqueous solution ai ba ko aqueous solution haiba maga amana non-aqueous solution haiba mako ani laigani ko aqueous solution and non-aqueous solution that depend upon the nature of the solvent ahan magi aqueous solution haibasina the solution in which the solvent is water akoigi solvent sina water oiba taragadi that solution is called akoina kai kore aqueous solution ko say for example aqueous solution of glucose haiba taragadi aqueous solution of glucose ta magi solvent water orani solutuna glucose orani haibane ba ko atopa mana non aqueous solution haiba ko non aqueous solution haibadi kaino ba kanda ngasagi the solution in which the solvent is not water nataba atopa organic solvent ether oibe yai benzene oibe yai carbon tetrachloride oibe yai ko aduna say for example solution of acetic acid in benzene ga harone ko aduna moisina kai singani non aqueous solution kaurani ko aduna akoi we also have two types of solution that depends upon the nature of the solvent amana aqueous solution where the solvent is water non aqueous solution where the solvent is not water high organic solvent oiba ko simalere limathang akoi amuk lokthara si yamaru oiba topic ni ko pekhado si am hangan ba ko concentration of a solution haiba ko aduna koi simal loigre concentration of a solution si koi define tours yamaru ore ko concentration of a solution amagi concentration haibasi kari no haiba taragadi it is the amount of the solute that dissolve in a given amount of the solvent or solution haiba the concentration of solution haibadi the amount of the solute that dissolve in a given amount of solution or solvent tumba adu akoina kari kawe haiba kana concentration of solution kawe aduna magi solute yauriba concentration gi matungina akoi solution se dilute solution haibasu yai concentrated solution haibasu yai aduna no lab ta thengnaramani koi dilute sulfuric acid koi concentrated sulfuric acid koi concentrated sulfuric acid to di kunna paiba yadena na koi tube amna tawra sin khalaga koi sina ba yai sina dina kai makana na kun payu tai na kutu satat kota ba tawdu ne ba that means concentrated solution da magi sulfuric acid ki concentration da wa janu wang bagi ne ba ko to de dilute sulfuric acid ti akoi dum lep magi keno da dum table da dum thammi mana mu dilute sulfuric acid na mu asai water ki solvent ki water ki amount jam ba that means solvent ki amount jam ba do sulfuric acid ki amount ni jam da ba anain tok dina koi magi depending upon the amount of the solute to gi matung ina akoi solution se concentrated solution hai ba yai dilute solution hai ba yai ko aduna koin hujik tawloi sina the ways different ways for expressing the concentration of solution natraga measurement of concentration of solution koi solution ki concentration onaba koi different ways lai amarom the unit higher su yai suppose na length si on get that we have different types of unit to measure the length koi length onaba gi unit yam lai dana ko meter bu hairo centimeter bu hairo kilometer bu hairo nine to dana koi gi solution ki concentration onaba different ways natra expression natra different units layeba ko adu mayam do koi one by one tam doini aduga mari leina ba numerical problem duni koi question pekha da yam hangali se ko duna khange koi na ujit na pigre what is mean by the concentration of solution. It is the amount of a solute that dissolves in a definite amount of solvent or solution that we call it concentration of solution. So let's do the different ways for expressing the concentration of solution. Different ways for expressing the concentration of solution or measurement of concentration of solution as you call. Ways for expressing concentration of a solution. Solution lamay concentration phungdo na ba concentration of a solution. Solution lamay ki concentration phungdo na ba ways maya natra unit mayam do koi one by one jenga si ko. Number 1 the mass percentage. Mass percentage magi somebody kamai e W by W high ko mass percentage high with both the solute and the solvent se animal loina mass we ko then mass percentage ko is minus p by it is the mass of the solute that dissolve in 100 gram of the solution high su ko then expressed to su it is the mass of the solute in gram that dissolve in 100 gram of the solution that is ko is minus by mass mass percentage of solute mass of solute divided by total mass of solution. Total mass solution ki mass kana pulaga semi mass of solute plus solvent pulaga semi dana the total mass hai ne ko smile mass percentage of solute means mass of solute total mass of solution into 100 total mass the mass of solute plus mass of solvent then usually in grams they expressed away. So let me give one example. See example se am na khang tare ko. Say for example 5% W by W solution of glucose high economic question solution of glucose smile irame khalo ko sina min to si kaino 5% W by W solution of glucose high na min to se sida solute se glucose hoy doni ko sina min to se 5 gram of glucose 5 gram of glucose is dissolved in 100 gram of solution high bane 100 gram of solution high bane ko sina min to 5% W by W solution of glucose sina min to se glucose is solid or any 5 gram of glucose is dissolved in 100 gram of solution adu tadi what should be the mass of solvent the mass of solvent ni kai manarani the mass of solution minus mass of solute the mass of solvent ni kaya tarani 100 minus 5 kaya tarani 95 gram tarani andai na puthok to ni ko to sidai ri bagi simo ji khang tare ko si mass by mass high percentage by mass similar mathang topa expression ani suba yengasi so this is mass percentage and understand tor mani khalamani ko understand tor mani mathang da mungla si ko volume percentage sai volume percentage volume percentage. Both solute and solvent se liquid ngak tu oido ko volume percentage hai ko B by B. Sumaina high C se it is the volume of solute in ml dissolved in 100 ml of solution. Aduna magi unit se ml the expressed to we ko volume percentage sai ta di it is the volume of solute in ml dissolved in 100 ml of solution hai ne expressed to we ko. Aduna se volume percentage of solute hai ne irame khaloko volume percentage of solute hai taragadi volume of solute divided by total volume of solution hai ko total ha pro ko volume of solution into 100. Say for example, see say understand tong na ba example mo pira ta ke yung ka. Say for example 10% B by B solution of ethanol in water hai ne ko. Sina min to sikari no. Say ethanol se kai waitare solute waitare water sina solvent waitare babani ne punjan ba solution na solution of ethanol in water hai tare. And then 10% B by B solution of ethanol hai ne min to se sina min to se kai no hai kanda 10 ml of ethanol dissolved in 100 ml of solution hai bane ko 100 ml of solution hai si ko na kai kore B by B volume percentage kore and 10 ml of ethanol dissolved in 100 ml of solution that we call 10% B by B solution of ethanol in water hai ba ko mathang do mu yengasi mass by volume percentage koi suba mu yengasi ko 3 da mass by volume percentage hai ba ko mass by volume percentage koi assembly da W by B hai ko sina min to si kaino it is the mass of solute that dissolved in 100 ml of solution hai ba ko koi 100 ml of solution da the mass of solute maroina usually in gram the p ko the mass of the solute in gram that dissolved in 100 ml of solution do ko ne kai ko kwanda mass percentage ko ko ana mass by volume percentage of solute and solute hape ko confuse that na ko do sina min to si kai no kanda mass by volume hai be se sina kai lani mass of solute maroina in gram da la kani ko divided by volume of solution into 100 siniko sini mass by volume hai je ko. So let me give one example 10% W by B solution of glucose solution of glucose in water hydro my solvent water where ko 10% W by B solution of glucose in water sida glucose na solute oil ni ko sina min tawr si karino haiba kanda sida min tawr si karino haiba kanda 10 gram of glucose dissolved in kaya tumba 100 ml of solution 100 ml of solution the tumba se koina kai kawi haiba kanda 10% W by B solution of glucose kawi ko silere. So this is mass by volume percentage. Mathang akhoi amuk laurasi mari subada ko gram per liter ko yam toin sinaba gram per liter haiba ko gram per liter mari subada ko yengasi ko gram per liter maya samase sumaina e gram per liter sumaina samba UCI shortcut ta sumaina UCI ko gram per liter hai bidi kai no hai bakanda it is the mass of the solute in gram per liter of a solution. The mass of solute in gram the pyramid that dissolve in per liter of a solution though that we call it gram per liter kawi. That is the gram per liter se kamani be yare gram per liter se smaini be yarani ko gram per liter equal to mass of solute in gram, mass of solute in gram divided by volume of solution in liter. The correct manangna solution is ml the p targadi divided by 1000 na divide to liter on thok da ko sini gram per liter ko re ko. The mass of solute in gram divided by volume of solution in liter. If the volume of solution is ml the pyramid target, it should be converted into the liter by divided by 1000 divide to liter on top of the ko. Similarly, manga subsidia maru ore noi taramani molarity madi mole per liter hai ko mole per liter aduga sambida capital M molarity. See definition is very important. It is the number of moles of solute. It is the number of moles of solute dissolved per liter of the solution. Dissolved per liter of solution. See kai kaure have kanda koi molarity kawi ko. The number of moles of solute dissolved per liter of solution je koi na kari kawi have kanda molarity kawi. The my formula say sadoke ng ko. Sita sadoke batak ta ko. Molarity se mu itoke formula ipi ge ng molarity. That is molarity equal to number of moles of solute divided by volume of solution in liter. What is number of moles? Number of moles I will the mass of solute divided by molar mass of solute. Molecular mass of solute. Some number of moles I will mass by molar mass I will the number of moles I will mass of solute. Number of moles means mass of solute in gram divided by molar mass molecular mass of solute. So this is number of moles divided by volume of solution in liter. High gram per liter mass of solute in gram divided by volume of solution in liter. High gram per liter high. Therefore, the molarity is molarity equal to mass of solute in gram divided by volume of solution in liter. Gram per liter gram per liter divided by molar mass of solute. Smile thamasu icon. Aduna solution ami gram per liter putoke hai the molarity into molar mass of solute. Hai na thamasu hai. Aduna koina molarity hot pakanda ai shortcut formula ama pige. Sumaina holuai na sumaina sum sang ita dino de matam mangani. Aduna ai shortcut oiba molarity ki formula am pige yung ko. Then pige dab se nang si khang tare ai na sinag dab tam se. Ayap kidya ayamana A sina solvent oi aina kawla pukan sina tu se ko B sina solute harakani ko lai kharda 1 2 haina haibisi yawi WB WA hai targadi angonda mass of solvent hairani ko WB hairagana mass of solute W sina mass haiba ko ID AB on sina rakani ko mass of solute MA MID molar mass haibani MA hai taragadi aingonda sinaktu se molar mass of solvent hairakani agi formula matungina ko molar mass of solvent dudagi MB hairagana molar mass of solute haigani ko aya kidaya masine aina haidi kari marang no lai kharada koi solute solvent se solvents na 1 iba yawi solvents 2 haini ibis yawi da aya kidade aya mana A B hain chalani ko si mayam je khangjalo si ki symbol mayam se A na solvent B na solute WA mass of solvent WB mass of solute MA molar mass of solvent MB molar mass of solute si khangdai hairiba si ki symbol mayam je sinaraga ai molarity si ki asamba formula ama ai noide pigi yam ko asamba formula ama pigi yam smaine ibe yare sam sambido ko molarity si palam hot pe yare molarity equal to WB into MB WB into MB B divided by 1000 last ko still later molarity the number of moles of solute divided by volume of solution the mass of solute number of moles mass of solute divided by molar mass of solute can select WB mass of solute WB molar mass MB see the B and the B say the volume of solution in ml the P bane see the liter high bane dana ko duna see the P ba B say volume of solution in ml the P ba say koina liter on thoke have targati 1000 divide tawni dana ko where the P ba B say karino hai ba kanda volume of solution ayamana ml the P ko volume of solution in ml the P adana molarity formula se kamai thambe yare si pala dum holo over ko molarity formula se yam line ko WB into 1000 divided by MB into B haina pala holo si pala dum hot pe yare ko WB into MB number of moles have mass by molar mass this is the volume of solution in ml ml is a liter on toke at 1000 divide tare WB into 1000 divided by MB into B haina formula se apply toraga na molarity se am line hot pe yani ba ko so this is the molarity mathang yamaru eba ma yenga si mathang da mu okay manga subada mu yenga si manga suba ko 5 subada normality si capital A na silicon ko normality habati karino haiba kanda it is the number of gram equivalent weight of solute dissolved per liter of solution haiba ko number of gram equivalent weight of solute se per liter of solution tummado ko na kari ko e kanda normality ko e ko ithok si ko it is the number of gram equivalents of solute dissolved per liter of the solution see ko na kai kaure normality kaure that is normality equal to number of gram equivalents of solute divided by volume of solution in liter or the number of gram equivalent haibati number of moles the mass by molar mass haidana ko anai to the number of gram equivalent haibati mass by equivalent mass of solute divided by equivalent mass of solute oidaba ko mass of solute in gram divided by equivalent mass of solute into divided by volume of solution in liter. Number of gram equivalents mass divided by equivalent mass. The mass of solute in gram divided by volume of solution in liters. Gram per liter. Therefore, normality equal to CD mass of solute in gram divided by volume of solution in liter. Gram per liter divided by equivalent mass of solute if you want to find out gram per liter, that we have done in the class 11 practical volumetric analysis gram per liter the gram per liter normality into equivalent mass Ngasagi nangi morality da in a shortcut of a formula in the same way, see the so a shortcut of normality formula ama ipg yung ka. Say formula ni toxic shortcut ko sima later. Di yang asiko shortcut touch mani iro normality haina tharo normality equal to and then high mass of solute in gram at WB the mass of gram mass of solute WB equivalent mass of solution E hierarchical into B by 1000 the sida kayoramani B is the volume of solution in ml the pyramid liter on top 1000 and divide over B sikaymanare volume of solution in ml the P volume of solution is the P ml the P. Then I say morality na W by W B into 1000 divided by MB into B haidana. Sidana kailani haibakanda W B into 1000 divided by E into B. MB mode E silani. So mina sigi formula sinaraga we can calculate normality hot payarani ko. Similarly. Adoitadi the scenery equivalent mass, the calculation of equivalent mass. See a note on the Tamatareko, equivalent mass of acid combined hot cani, equivalent mass of base na combined hot cani, equivalent mass of its holes in a combined hot cani. We can give the relation between the morality and the normality of the same solution. Same solution lamagi normality and morality ga relation combined lay. High singsina akoi equivalent mass po holamasi the relation between the normality and the morality of solution na mathangi class ta torasi akoi how to calculate the equivalent mass si no in thamas equivalent mass po holamasi ko equivalent mass hosi akoi calculation of equivalent mass se no in thamasi ko koi equivalent mass se kamai hot ka dege haiba khamam sange ko normality puto pada calculation of equivalent mass se koi khangbam sange ko se nang note when thamo NB the equivalent mass of an acid I something like EQB ani irage ko equivalent mass of an acid lamagi equivalent mass combined hot kani haiba kanda molecular mass haibani molecular mass of acid divided by number of displaceable hydrogen hydrogen ion replaceable number of displaced hydrogen ion from one molecule of an acid haibako si asamida kai ko ikanda basicity the number of displaceable hydrogen ion from one molecule of acid basicity so let me give one example example equivalent mass of a cell silere ti kailani molar mass of a cell molecular mass molar mass of a cell divided by basicity the number of displaceable hydrogen ion in ICL the 1 tarani aduna ICL se koi mono basic acid so hai nei ko the molar mass ti kado phangani magi atomic mass in general phangani. What is the atomic mass of hydrogen? 1. Atomic mass of chlorine 35.5. magi basicity number of displacement hydrogen ions is 1 oibanina kaya tare 36.5. so this is the equivalent mass of ICL oirani ko aduna ICL se basicity 1 oibanina koina mono basic acid haina su khangnei ko. Tang the 2 the last si ko equivalent mass 2 the acid dum isal lage ko 2 the similar 2 simuthal lage ko simadum thamge example ore even ngai na ko sina equivalent mass of a base anu thu si ko equivalent mass of base weta the molar mass of base arani ko molar mass of base the number of displaceable hydroxyl ion na koi base lo do se hydroxyl ion yaw base lo rani ko number of displaceable hydroxyl ion from one molecule of a base hai tare ko one molecule of a base sia koi na kai ko ya ba kanda acidity ko we call it acidity acidity amana basicity hai adana equivalent mass of a base is given by molar mass divided by acidity. Acidity is the number of displaceable hydroxyl ion from one molecule of a base hai ko adana. Let us give one example. Equivalent mass of sodium hydroxide silere hydroxyl ion 1 jaroni ko adana the molar mass of sodium hydroxide divided by acidity number of displaceable hydrogen ion hydroxyl ion is 1 jare molar mass the atomic mass is naro sum of atomic mass of the elements present in the molecule ka atomic mass of sodium the 23 lae atomic mass of oxygen 16 atomic mass of hydrogen 1 tarani si total se 40 tabani ko 40 by 1 kya tarani 40 tar. So this is the equivalent mass of sodium hydroxide. The last one matang jengasi ko the equivalent mass of salt haina ko the equivalent mass of base kange molar mass divided by acidity means number of displaceable hydroxyl ion from one molecule of base dumalaire ko matang the last one antang yengasi ko equivalent mass of a salt hai ko koi ahum subada equivalent mass of a salt whole acid ka base ka loigre ahum subada equivalent mass of a salt salt is normal salt oi hydrogen ion si yaw daba hydroxyl ion si yaw daba ko ketain ma ge anion ma yaw daba ko salt HCl gumba ko sodium chloride gumba calcium chloride gumba ko kailani molar mass of salt divided by total valency of metals or non-metal total valency of metal or non-metal high metal and non-metal yaw salt oidoni ko say for example si bodi sinaroi ko equivalent acid ka base ka duni am to sinadoi si ko equivalent mass of NaCl sodium chloride salt ni ko ketal magi anion ma yaw re ta the molar mass of NaCl the valency of sodium laurisico valency of sodium wala ni ko C plus oxidation state plus 1 minus 1 the molar mass the mass in general 35.5 divided by valency of sodium 1 is क्या आता है 58.5 divided 1 तो क्या आता है 58.5 स्पाइन तार निको. So this is the equivalent mass of sodium chloride कोई so far कोई हुजी normality बक तौरे मथंगी class तो कोई तो measurements of कोई concentration of solution ओ नब खरा वाले अदुसो कोई तमथरसी अदुगा the relation between the normality and the morality of the same solution हाइबन सिंगबा numerical problem सिंगबा अदुना कोई मथंगी class तो मु कोई चथनबो होनरसी. Okay.